What if you want RGB lighting on your RAM or SSD, but you don't want to buy a new device just for some shiny lights? Well, let's look at what options you've got. Hello, I'm Guy, and this is Guy Robot. I've been working on rebuilding my workstation. The whole system is worth about $12,000 after its recent revamp, and RGB was high on my priority list. That's really difficult to do with server-grade components though. For some reason, racked kit and consequently workstation kit doesn't really get much of a love-in when it comes to LEDs. There's not even an option for me to buy RGB RAM, as I have to use ECC memory in this board. Furthermore, my RAM is spread across 4 memory banks, which means something like the Corsair Dominator or dedicated water blocks was going to become very expensive very quickly. I've got a similar problem with my SSDs. I use a 970 Pro as my main SSD, and I've got a 970 Evo as well. These are amazingly performant drives, and nothing with RGB comes close to that. Not just that, but my StarTech NVMe PCIe card is about as ugly as they come. Now, I know that the idea of RGB is ridiculous. I don't care, I still want it. So that limited my options somewhat. Thankfully, a generic brand called EZDIY-FAB came to the rescue. They seem to be focused on eBay and Amazon sales and provide RGB for, well, everything. They've got RGB RAM heat spreader covers as well as PCIe NVMe cards with NVMe heatsinks. What's not to love? Now, there's a lot of options. So let's look at the RAM heat spreader on Amazon. There are 12 different variants. They seem to come down to a choice of colour, quantity and the type of RGB. And there are 3 options here. The first is to have non-intelligent lights that just cycle rainbow colours. These use a fan header. This is definitely the easiest option if you're working on a system without RGB headers on the motherboard. But, wasn't for me. Then there's the option of 12 volt or 5 volt addressable LEDs. 12 volt LEDs just set a static colour across all the lights, whilst 5 volt LEDs are addressable. I opted with 5 volt addressable LEDs and purchased a single controller. I've also got 8 sticks of RAM, so I bought 4 sets. I'm hoping I can run these off a single controller. There are similar options for the NVMe PCIe card. The card itself has 2 sockets, an NVMe socket as well as a SATA M.2 socket. But to use the SATA socket, you actually need to run a SATA cable to the device, as it doesn't come with its own SATA controller. I purchased 2 of these for my NVMe cards, and I kept my standard Western Digital M.2 SATA SSD in the motherboard socket, since I didn't want to route extra cables in this build. I have a feeling that this many LEDs is going to be difficult to run. Looking at the pictures online, the RAM spreaders have 7 LEDs, whilst the PCIe NVMe cards have got about 12 each. So that's a total of, what, 80 LEDs? I'm guessing based on the bright spots in the Amazon product pictures at least, but that feels about right. Assuming a maximum draw of 60 milliamps per LED, that's like 4.8 amps of power that these can draw. I don't even know if they're daisy chainable, but let's open the box and let's see what we've got. So here we are. I've got 3 different types of box here. We've got the memory heatsink with a controller. We've got the memory heatsink without a controller. And we've also got, in very much the same box as we had earlier, this is for the NVMe heatsink, which doesn't have a controller. So all of these should be 5 volt addressable ones, and we should have 1 controller here. Failing enough controllers, I've also got a Fantex 5 volt addressable controller, which we'll be able to use. Now, other than what's actually the product type, the box doesn't give a lot away. We just have these kind of generic Chinese, like a couple of ticks and colours for the absolute minimum on packaging, but should be enough to get going. So the one I'm opening first is the NVMe controller. It comes with a beautiful anti-static bag. Ooh. Watch me use absolutely no precautions when I get something out. My first thought is it looks like a fairly cheap Chinese card, but it's got a lovely twang to it. But it was a cheap Chinese card, so I can't really knock it at that. So we've got a socket here for the NVMe. We've got a socket here for the SATA one. Then if you want the SATA one, you need to piggyback a SATA cable out of there. Goes into PCIe socket, and that should give this power to actually have RGB lighting as well. Now there's also a button on the back that lets us change an RGB mode if we're going to use the onboard controller rather than using a software one. And we've also got 2 connectors here for RGB going into the PC. The box also comes with a right-angled SATA cable, which is always helpful if you need it, which means you can connect the SATA port if you have lost your own one. And then we have a connector for the RGB as well. So this helpfully comes telling you not to plug it into the 12-volt one on your motherboard, but to only plug it into a 5-volt addressable one. And it also comes with a little cable that I guess is for daisy chaining it, not quite sure here. So we've got this one cable, the idea is it goes into your motherboard, and one end goes into here, so nice and easy, bang, that one goes into there. That can go into this one. And then from there, that goes into your motherboard to provide control for it. It's got a two thermal pads, a screw, and a tiny screwdriver to actually heat sink it to your computer. And there was even a little cover on one of the cables. So not bad. I'm looking forward to actually plugging this in a minute and seeing how it goes. For the RAM heat spreaders, I imagine we're going to have similar, but we should have a controller in this one. Exciting times. Ooh, cheesy remote control, and that looks like a teeny tiny controller in there. So we've got two RAM heat spreaders here. They're actually, I'll be impressed. It's better than I thought. I thought it was going to be really, really terrible, really cheap, flimsy metal. It's not. It's a fairly substantial one. It doesn't look terrible. Same 5-volt connectors we had on the other one. So there is a male and a female with a cover to stop you bending the pins in the packaging, which is actually a nice touch for something that's so cheap. And again, we've got thermal strips. So these aren't just to look pretty. The idea is they've actually got thermal strips to try and take heat away from your RAM. And all the connectors and things we need. We've got a second one in here as well, and then we've got an extra cable for going from your motherboard header into these. Now, these ones look like they're daisy chainable because we've got the male and the female side, so the idea is that we can daisy chain all of the RAM together, which is good. So, for example, I can take this one out as well. I can get the male end of that one, I can pop it into the female end of this one here, and then if I want to, I can get the NVMe one and I can plug us into that one, and then I can daisy chain the whole lot into the motherboard. So we can run the whole lot off one header, which is actually pretty darn good. Now, when it comes to the controller that comes with it, it is a fairly generic controller, but it saves me having to do the work. So with this, we've got a Molex 5-volt power cable, which then has a teeny tiny controller just embedded in this bit here. This then will go into there, and then we'll be able to control the various patterns and things with our remote control with a battery attached. So this should mean that all of our 5-volt stuff we can run off probably a couple of these controllers. Might need some more of these controllers, but that's a good start. So now it's time to actually install the RAM heat spreaders. These do come with a set of instructions, which I'm not going to even try and show to the camera because they're fairly rubbish. They kind of make sense, they're just poorly written and poorly described. So it mentions EVA paste, not sure entirely what that is, and thermal paste, which is actually a thermal pad, but we can figure it out from the pictures fairly easily. There's two different sets of instructions, one if you've got low profile RAM and one if you've got normal sized RAM. The difference is whether you use 2 thermal pads or 1 thermal pad and some plastic raisy bits and the mysterious EVA strip. Because I've got normal RAM, let's just get out the 2 thermal pads. Really helpfully, they actually put in a spare screw in here, which when you're dealing with tiny, what's this, 3 2mm screws, I tend to lose them, so it's nice to have a spare one in here. So what we're going to do is take out the 2 screws on the side of it, lift away the top, and then this is a bit loose once we're inside. You can actually see the strip. There's 1, 2, 3, 4, 5, 6, 7, 8 LEDs on there, just on a super tiny 5-volt addressable strip, really thin. And then what we need to do is put these thermal pads on. Rather than sticking it to the RAM, I think the thing to do here is to put it onto the actual plates themselves, because that's going to be easier because there isn't a huge amount of room. The pads are cut down to the exact width of this. So rather than sticking it on the RAM and hoping it doesn't go onto the top bit or go too close to the pins, I'm just going to stick it onto the heat spreader itself. It doesn't make it clear in the instructions which way you're meant to do. The other thing I'm probably going to end up doing is chopping some of this off, because as you know, when you put thermal pads on, they stretch a little bit, and these are at the moment the exact right width. Before we put the RAM in, we also need to figure out which way this is going into our system. So in the memory slot this one is going into, I want the cable coming out on the right hand side. If I put my RAM chip in the wrong way around when I install this, the cable is going to come out on the left hand side, and then cable management is going to become an absolute bitch to sort out. So let's make sure I put my RAM chip in the correct way once I put the thermal paste on. So first things first, let's take off the 2 protective strips from the thermal paste. Put the thermal pad onto the heat spreader. I'm actually going to put the thermal pad in the kind of the middle of the heat spreader rather than right at the bottom, because I've got some of my chips have got 2 different rows of memory chips on them, and that way it's more likely to cool all of them. And as expected, it grew a little bit, so we've got kind of a centimetre or so to cut off. Do the same to this side, careful not to lose the screws. And on this one I'm going to put it actually at the bottom, because I don't want to go up too far onto the bit where the RGB is. So this thermal pad is the one I'm going to put just a bit closer to the bottom, and chop that one off. Put this back on and then screw it together. Job done. We now have RGB heat spreaders on server RAM, which is not something I ever thought I would do in my lifetime. But hey, shiny LEDs and super expensive ECC RAM. What's not to love? All I have to do is repeat this for all of the rest of the RAM in my system. So now we've got all the RAM done, it's time to do exactly the same thing, but with the NVMe M.2 version of the device. As far as I can tell on this one, again, we've got some instructions that are less than stellar. It basically looks like there's 4 screws on the back that come out, and then there is 1 thermal pad provided for each of the 2 drives. Now remember, these ones have got both a SATA and an NVMe slot in them. I won't be using the SATA one because actually it's just got a SATA port there on the board, and so you then have to relay that into your motherboard SATA. Now personally that feels like a bit of a waste, because then I have to have an extra cable dangled everywhere. I get it if you want to have some RGB in your case, but frankly you could still use your motherboard directly rather than using this and just have the RGB lights. But I do, however, want to use my NVMe drive, so I'm going to use 1 port on each of these. So just need to make sure it goes into the NVMe rather than the SSD port on the thing. So I'll have a quick look when this comes off. So we've got a retention plate, we've got the space for the M.2 drives. Something else that's worth mentioning then is that these screws by default are not in the full length position that would be useful or that you'd expect, so we are going to have to move them down a little bit. When you're doing anything like this with NVMe or any M.2 device, do not lose the screw. Cannot emphasize that enough times, because normally all these, there is no standard for them. So if you lose the screw or you lose the mount, you are frankly screwed, pardoning the pun. Okay, so there is a tiny screw, it doesn't screw directly into the board, there is a tiny screw that goes in behind. You need to not lose that as well when you're doing this. And then screw it back in. Don't over tighten it. I have a suspicion the screw head is so tiny on this you'll tear it. Now helpfully in all of these kits, I haven't mentioned, they give you a little screwdriver. I can't really see what the point is, as it would not actually help you move those screws, and presumably if you're dismantling your entire computer and installing M.2 devices and your own heat spreaders onto RAM, you probably own a screwdriver. I guess it's a nice thing to do, but it does feel a little bit silly. Now these screws are absolutely tiny, so do not over tighten these, and there's no spare. Bizarrely they put a screw in here for retention into your case, which I guess is useful if you have a really cheap case that doesn't provide you any screws or you lost them all. But what would be really useful would be a spare one of those screws in case you're using both devices and you accidentally tear a head. We need to put our heat spreader on. Because unlike RAM, which doesn't really need a heat spreader, and let's be honest, it's just to look cool, these bad boys can get incredibly hot when they're under operation, particularly if you're using a lot of throughput on them or if you're doing kind of IO intensive workloads. So covering them with a piece of metal that acts a bit like a radiator is probably not the best idea unless you've got a heat pad of some kind to transfer that away. That's actually surprisingly difficult to line up when the thermal pad is acting like glue on the thing. This is why a lot of manufacturers only actually make the thermal pad sticky on one side. All of the thermal pads here are sticky on two, which can make it a bit more tricky to get those screws in. And you obviously don't want to put too much stress on this considering the value of your cards underneath it. And now I've got to say, even without putting the LEDs in there and plugging this in, do you not think this looks remarkably better than the red StarTech one, which I know StarTech make really good cards and I like StarTech, but it's not quite as fun, is it? So goodbye StarTech, hello EZDIY-FAB. These need to go into my case and I need to do the other one. You know what? I love these products. I really didn't think I'd say that when I bought them, but they over-delivered in terms of my expectations for what I thought was some cheap Chinese stuff off Amazon. Now this build has a lot of RGB components, and some, like the Lian Li RGB cables, were really expensive. The EZDIY-FAB stuff was super cheap and actually looks really good. I'm happy with how the whole thing installed, the overall build quality, and the light levels on them. The one thing I would say is that the 5V addressable RGB controller that you can buy with it can have issues. One didn't work for me and one overheated and blew up. I'm on my third one, which seems to be fine. That being said, when it does work, it has a really good mix of lighting effects that are pretty impressive, especially considering the cheap cost of the controller. I'm honestly more happy with the lighting I get out of this than some of the more expensive ones I've tried. Now, if you're looking for RGB RAM or SSDs, then I definitely think this is the way to go. It allows you to keep your preferred RAM sticks or to buy RGB-free RAM at a much cheaper price and then slap the RGB on top. In my system, it all looks really good. I expected it would actually look a bit tacky, but it might be tacky, but I think it looks great now it's installed. So I like these, they're easy to install and they look good. Job done. Well, I hope you found this interesting. I tend to not do many install and unboxing guides, but I couldn't find much when I was looking for these on the internet and I was worried about the quality, so I thought this might help somebody else. So what do you guys think? Was it worth the money and has it made my system look better? If you're looking at buying them, which bits are you considering going for? If you've already got them, how have they held up for you? Let me know and leave your comments down below. If you like this video, hit like and subscribe, and you can also catch me on Twitter at GuyRobotTV, and I'll see you next time. Thanks.